All right, I'm going to try to do a quick run-through of graphing, factored form, general form, vertex form. Depending on what day you're looking at this, you may not have covered vertex form. In case, ignore that, but these are all good tricks for graphing. Obviously, we can plug in points. We can plug in 0 for x, we can plug in 1 in for x, we can plug in -1 for x, and find points that work. But that's kind of cumbersome, and there's some tricks that usually prove useful in more quickly finding what this graph looks like. So this is a factored form. General form is I could FOIL it out, or you use this, but basically I can do this in my head. X times x is x squared. -4 times x is -4x, but then the last term's 2x, so when I add -4x and 2x together, I get a -2x, make sure that's right, and then -4 times 2 is -8. Okay, so that's the general form. There's one more form called vertex form that I can turn the general form into, and that requires completing the square. So to do that, I do y equals x squared minus 2x. I put the -8 over here, and I'm like, what makes this a perfect square? I want to turn this thing right here into a perfect square. I know the pattern is always half this number squared will make this into a perfect square. So half that is 1, or -1, squared is a +1. That is now a perfect square. But since I added in 1 right there to keep my equation balanced, I need a -1. These two offset each other, so effectively I've added 0. All right, so I can rewrite this. This is the same as x minus 1 squared. You can check that on your own, but x minus 1 times x minus 1 is that right there, -9. When it's written in this form, it immediately tells me my vertex. Okay, my vertex is going to be this number and this number. Okay, so the minus has got to be there, so it's whatever this thing is minus. So if it was a plus there, I'd have to change it to a minus, and that'd be a negative. Okay, so once again, if that was a +1, the x value would be a -1 for the vertex. And then this is always this number out here. Or if you want to think about it, there's a plus there, and whatever the plus is, it's that. So that needs to be a minus, it's that number, that needs to be a plus, and then it's that number right there. So this is going to have a vertex. We know it's going to go down to 1, -9. Really quick way to find that. Okay, I'm going to move on. Okay, X-intercepts. If we've got it in factored form, that's super simple. It's 4, because 4 minus 4 is 0, which makes y 0. So when I plug in 4, that becomes 0, and y becomes 0. And a -2 there will cause that factor become 0. And so when I plug in -2, that's 0. All right, so now I've got 1, 2 points. Okay, another trick, which we may or may not have talked about. If I plug in 0 here for the y-intercept, I'm going to jump down here. I'm going to move this now. Right here, the y-axis is x equals 0. Some people, that's a little confusing. X equals 0. So if I plug in 0 to this equation, it should be super obvious that, oh, y is equal to -8 right there. I can plug it into here, maybe not quite as obvious, same answer. But if I've got it in general form, put a 0 there in, I can say immediately, oh, my y-intercept is 0, -8. Once again, I'm just plugging in 0, but that's a quick trick. If I'm in general form, I'm like, oh, it's what's left over there when I plug in 0. All right, I got 2 points. I need 5 points. Okay, so I need get my reflection point. That's really actually easy enough, and my vertex, which depending if you've done vertex form, is easy enough. All right, so let's just stay down here with the reflection point. So I have 4, I have -2, I have 0, -8, which is right there. There's 3 points. I want 5 to make sure I've got this. And I actually know where my axis of symmetry is. There's 2 ways I know this, or my line of symmetry. It's halfway in between there, so I could add those 2 numbers and divide by 2. So 4 plus -2, that's off the screen, divided by 2 is 2 over 2, or 1. So x equals 1 is halfway between there, so I know I'm going to have an axis of symmetry right here. That's one way we know it. Okay. There is another trick that says that's also going to be equal to -b over 2a, where the b is the number in front of that, and the a is the number in front of that. So if I plug those numbers in, I get the opposite of -2 over 2 times 1, which you'll notice that is also 1. So any way I want to do that, I can find my line of symmetry is equal to x equals 1. Multiple ways to do things in mathematics. You get to choose which is easiest for you. Now that I have this, I can find the vertex by plugging it back into either equation, or if you've done vertex form already, you already have that. So if I plug my 1 back into either equation, I should get -9. Or if I've got it in vertex form, I already know that my vertex is 1, -9. All right, so I've got almost all my points. I'm going to put my vertex point in green. The reflection point, think of this as a mirror. This reflects 2 away, 2 away. This is 1 away. This point out here will always be this distance from the y-axis to the line of symmetry, and then once again. So it's twice as far. So I know if my line of symmetry is at 1, the reflection point is going to be twice as far. It's going to be at 2 something. They've got to be on the same line. I could plug in if I wanted to check myself, but I don't need to. I'm like, it's got to be that far away. It's got to be on the same level. So that's going to be -8. All right, I do sometimes check this. I plug 2 into the equation, make sure I get -8. If I don't, somewhere along the way I've made an error. So that is a nice way to check it. And then I can nicely connect my thing, try to make it curved at the bottom, and these do go on forever. The line there is not necessary, but I like to draw it in sometimes. Okay, that's real quick. I want to show you what changes if you have a leading term. And once again, there's the vertex form. You can freeze the screen and look at that if you need to. All right, down here, same thing. General form. Oh, actually, I've got it in general form, so I want to change this to factored form. So to factor that, first of all, I'm going to pull out a 2 because I have a common factor in there. So that's this. And then somehow I have to factor that. I can use the box, the area model, or I can just try to figure it out in my head. But this ends up being 2 times x minus 3 and x plus 1. That is the factored form. Okay? So that is my factored form right there. All right. In factored form, I know what my zeros are. The 2 does not affect it. The 2 is what's called a scale factor. It makes it either taller, stretched out, or more compact, compressed, but that does not affect the zeros when it's in this form. So I know automatically my zeros are going to be at my X-intercepts, which are also called zeros, and they're also called solutions or roots, lots of synonyms for those. Those are going to be my intercepts. Move this up, make sure you can see it all. My vertex form, going back to my factored form, y equals 2x squared minus 4x minus 6. I'm once again going to separate these, but I'm also going to pull out the common factor in these two. Okay? So the minus 6 is still out here, but these have a common factor. I want to pull those out. I do not know how to complete the square if there is not a 1 in front of my x squared. So for those two terms, if you ever got something out here, you're going to have to divide out whatever that is. Oh, this one's easy because it's kind of the same one we had before. Okay? I didn't mean to do that, sorry. So same thing, plus 1. And then so I plus 1 there. Now I got to be careful here. Technically, I've actually added 2 because that 2 gets distributed. So to offset that, I have to minus, oops, off the screen, sorry, minus 2. So that was my minus 6 I brought down. I put a plus 1 in there, but ultimately that's got to get multiplied by 2. So I got to do a minus 2 out there. All right, and so then I can rewrite it. This is 2x minus 1 squared minus 8. Okay, I hope I did this right. Oh, it's a slightly different graph. Okay, it's not exactly the same graph. It's pretty close. Okay, so my vertex is at positive 1, and I can rewrite this and say, oh, it's negative 8. That is where my vertex is going to be. Another good clue here, your vertex should always be below your x-intercepts unless there's a lead negative number. We know if there's a negative number on the x squared, it flips the graph upside down and it looks like that. Okay. So that's a good check. If you suddenly get a positive number and you know, wait a second, why is this above? And there's no lead term, you're like, I made an error somewhere. All right, I'm almost out of time. Line of symmetry, I'm not going to do the rest of it. I just wanted to show you how to do that. That was the one thing that's different. This thing will be, when I graph it out, it will have points at 3 and -1. I've already figured out this is at 1 and -8. I actually will have a, if I go back and figure it out, I'll have a y-intercept at negative, oops, sorry, right there, did it in the wrong place. It's right there. There's my y-intercept. It's 0, -6. And we already know this is 1, -8, which means that's equals 1. And then there's my reflection point right there. Okay, so this is what this is. Hopefully I haven't gone over time. Thanks.